Hello everyone. In this video, we are going to determine the inverse function given the restriction, and this is the first part. Let's take this first example right here. Determine the inverse of the function given the restriction f of x is equal to 2x squared minus 5. The restriction that we have here is that x should be greater than or equal to 0. So we are going to sketch the graph of this so we know what do we mean by this restriction. So I have here this piece of paper. I will show the graph of this given function. So I'm just gonna write that up here. Okay, so given the f of x right here, which is 2x squared minus 5, so I'm just gonna write that down here. We can actually change this to its graphing form, which would come out to parentheses x plus 0 squared minus 5. So that from here we can go ahead and say that our vertex, just by looking at this, our vertex would be, remember we switch and keep, but since it is 0, it doesn't really matter. So that we can go ahead and say that the vertex of this graph that we have here would be 0 and negative 5. So remember, we are supposed to keep this. So again, the 0 doesn't have to be a negative or a positive, so we can just write 0 in there. And it also doesn't matter if you minus or add the 0, because adding or subtracting 0 doesn't really change the value of x. So our vertex is at 0, negative 5. Now we are going to, again, our task is to graph this function that we have up here. Now our next task here is to write the equation to complete the tables. I'm just going to write that up here. Okay, so the equation that we are going to use is, we remember that we are supposed to cover the h and k from this graphing form, so that we are left with just y is equal to 2 and x squared, because I covered the h and the k. So then we can go ahead and say that from the vertex or from the locator point, okay, so what are we going to do is we plug this value of 1 to the x right here. So our work, we're going to show the work on the side right here. So this would come out. We use this equation. So that would be 2 parentheses squared. And then the one that we put into the parentheses is this one right here. So we put a 1. So 2 times 1 squared is equal to 2 times 1. So then that is actually equal to 2 right here. So that's a positive 2. Positive 2 means we go up. So from the vertex, this means that from the vertex, we go 1 right and 2 up. And then we plug this 2 into this equation again to fill this cell right here. So we can go ahead and say that we use this equation. So that would be 2 parentheses squared. So again, inside the parentheses would be this one right here. So that would be 2. So this would come out. That's going to be 2 times 2 squared is 4. So that is equal to 8. So then I go ahead and write 8 up here. Since this is positive, that means we go up. So we are now ready to sketch the graph of this function right here. We can go ahead and say that the vertex that we have is at 0, negative 5. So 0, negative 5 is right here. And then the next one we have is from this vertex. So this is our vertex. We go 1 right and then we go 2 up. So 1 right and 2 up, 1, 2. So this is the next dot. And then to get to the next dot right here, we go ahead and say 2 right from the vertex. It's always from the vertex. 2 right and then 8 up. So 1, 2, 8 up. 1, 2, 3, 4, 5, 6, 7, 8. So this is where the next dot here gonna sit. So then we go ahead and say, so since this is a quadratic equation, we go ahead and reflect it on the other side. So then we go ahead and draw this parabola that we have right here. So I can go ahead and sketch this. Okay, looking at this graph right here, this is not a one-to-one function. Again, to test if it's a one-to-one function, we are going to pass a horizontal line, or we're going to use the horizontal line test. As you can see here, if I pass a horizontal line along this graph is touching the horizontal line twice. So then this fails the horizontal line test, which means that this is not a one-to-one function, and so it means that this does not have a inverse functions. This does not have an inverse function. That is the reason why it has to be restricted. Restricted means we only consider a part of this graph. It says here that it should only be x is greater than 0. So when we say x is greater than 0, we are going to pick the value that is greater than 0. So the x is 0 right there. So anything that is greater would be the only one that we consider. So that we can go ahead and say that we can erase this part right here, since this is not part of the restriction. Okay, so after erasing the other branch, again, we erased it because this branch right here is not greater than or equal to 0. So this is the leftover right here. So we can go ahead and say that this is the part of the graph that we only consider after we restrict it, so that we can go ahead and say that this graph already passes the horizontal line test. Because if I pass a horizontal line on this graph, it's touching only at one point. So then we can go ahead and say that this is already a one-to-one function, so therefore it has already an inverse function. So looking at this graph right here, we can say that the domain for this graph, which is the one that is restricted already, the domain for this is x is greater than or equal to 0. So anything that is greater than x is part of the graph. Again, we already erased the other branch because it is not part of the restriction. Now the range that we can have here would be that's gonna be above -5. So that means y is greater than or equal to -5. So that is the domain and the range for this graph. So then we can go ahead and determine the inverse for this restricted graph right here, or this restricted equations. I'm just gonna show the work for the inverse right here. We remember that we are given this function that is. The first step in determining for the inverse of a given function is to replace f of x with y. So this f of x will become the y, and that is equal to 2x squared minus 5. Now the second step is to replace every x with y and every y with x and solve for y. So that we can go ahead and say that this would come out x is equal to 2y squared minus 5. So that's the part of the second step. Again, it says that we're supposed to solve y by itself. So we're going to add 5 to both sides. So that would be plus 5 and plus 5. So that we can cross the 5 out. We are left with x plus 5 is equal to 2y squared. Again, we are supposed to solve y by itself. So that we can go ahead and say that we divide both sides by 2. So that we have y by itself. So that we can cross this out. We are left with y squared is equal to x plus 5 over 2. Now, we want y by itself, but that's a y squared, so that we can go ahead and square root both sides. So square root this and square root this, because the antidote for squared is square root, so we can cross this out. Now, we remember that if we square root both sides here, this will have two values, a positive and a negative. So then we can go ahead and say that the equation that we have here would be. So the problem here is that which one do we pick? Are we going to pick the positive or are we going to pick the negative? Now, if we look at the restriction right here, it says it's greater. Now, I'll give you a trick. So if you have a restriction that is greater, we pick the positive so that we go ahead and say that our final equation for the inverse would be the one which has the positive. So again, because again, that is greater than, so we pick the positive. Now we're ready to move on to the third step. The third step is to replace the y of the equation solved in step 2 with f negative 1 of x, so that we can go ahead and finally write the inverse as that is f of negative 1 of x is equal to, that is the positive square root of, we can actually simplify this one right here. We can also rewrite this as actually y is equal to, that's positive, that would be, we take the 1/2 out, so we factor it out, so that would be 1/2, so that it's gonna be in graphing form, so that would be 1/2 x plus 5. So these two are pretty much the same thing. We just changed this to graphing form, so we know what the h and k is, so it's easier for us to graph. So then we can go ahead and say that the f of negative 1 of x is actually 1/2 x plus 5. So this is our inverse for this function that we have right here. So I'm just gonna put that inside the box. Again, our restriction here is that x is greater than 0, and so we had to pick this positive part of this solution right here. So if this were x is less than or equal to 0, then we would have picked the negative one. But since that's a positive, we picked the positive solution. Now we are ready to sketch the graph of this inverse. So I'm just gonna show the work on this paper up here. Okay, so again, our equation for the inverse, we can just go ahead and change that to y. So that would be y is equal to, that's the positive square root of, you don't have to write the positive, that should be fine. That is 1/2 x plus 5. So just by looking at this, we can change this into its graphing form. We can tell that this is, the k here is plus 0, so that we can tell that our vertex for this is, remember, we are supposed to switch and keep, so the vertex here is negative 5, and then that's a 0. So that's our vertex. Now we are now ready to determine the equation to use to complete the tables. I'm just gonna write that down here. So the equation that we're going to use would be y. Remember that we are supposed to cover the value of the h. So I cover this, and at the same time, we cover the value of the k. So I cover that, and whatever the leftover is, that would be the equation that we are going to use to complete the table. So that would be y is equal to, we don't have to write the positive right there. So that would be y is equal to 1/2 x, because the rest were already covered. So then we go ahead and write from the vertex. Okay, so we are going to plug this value of 1 and 2 right here to this equation. So I'm just going to show the work on the side here, how we fill this table in. So that would be square root of 1/2, and then the x again is this value. So I put in the 1 right here, so that is actually equal to the square root of 1/2, or the square root of 0.5, which is approximately 0.71. So I'm just gonna write that up here. So 0.71, since that is a positive, so we go ahead and say that we are going up. Now we plug in the value of 2. So I'm just gonna show the work on the side right here. Okay, so then we can go ahead and sketch the graph. So we go ahead and say that from the vertex, we go, by the way, the vertex right here is negative 5, 0. So that's negative 5, 0 is right here. And then we can also tell that the table here is telling us that from the vertex we go 1 right and 0.71 up. So 1 right, 0.71 up. So it should be somewhere around here. and then 2 right from the vertex, we go 1 up. So 1, 2, 1 up. So it's going to be right here. And then we connect these dots together. And so we are able to draw the graph of the square root function. So I'm just gonna show the graph up here. So this is our graph of the inverse function. We can tell that the domain for this graph is actually, again, we go to the x value. So the domain here would be x is greater than or equal to -5. While the range that we have here, so up and down, so the range here would be y is greater than or equal to 0. So then I'm going to use a different color for the function and the inverse. Okay, looking at this, we can tell that these two are symmetric to each other with respect to the line of symmetry, which is y is equal to 1. So I'm just gonna draw the line of symmetry for this, which means that if we fold this graph here across the line y is equal to x, we can tell that they're going to sit on top of each other. This means that the inverse of this restricted function right here is this one. Please remember that we picked the positive and not the negative because the restriction was x is greater than 0. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!